Chapter 8, Pointers and Array in C language. Pointer and addresses. In fact, we already covered some pointers and some addresses and some arrays so far. And here in this chapter, I try to focus on C language for, again, these different topics. First, let's review a few things. Number one is the memory model. In fact, we have a memory model for C language. Primarily, you have a data section. You have a instruction section. You have a stack. And inside the stack and stack section, there is another thing called heap. Okay, so whatever you use memory allocate or C allocate in C language, or you use new in C++, this data will be put into heap. Global area will be put into your data segment, and then local variable will be put into stack. So that's the memory model we have so far. Okay, so again, today we are going to talk about pointer and the array, and maybe some structure as well, and will be strongly related to memory addresses. And these are the important part for C and C++ language. I'll cover both language, try to cover both of them, okay? So memory divided into 1 byte pieces individually addressed. So basically, each address you can have a byte, a bit, and each one has a memory location. Usually we use that. So you have the certain address and certain address like that. So these two, actually, one is called segment. The other one is actually inside the segment, you have a local address. So usually the segment and address, you have a certain memory calculation scheme, you know, some sort of plus or minus. So that part actually in the assembly course or in UCL Advanced ICS 51, I will cover that. So let me actually briefly talk about this address calculation in C. So let's look at the, let me bring up browser. So here I say segment address and local address, something like that. So let's look at the image. Okay, so whatever image that we shown here actually is something that usually will access your memory. So in x86, you have memory segmentation. So something called discretion table, it would have two part of the address, linear space and segment size, okay? Segment size. So each one is a segment. Each, we can call it a page or something. So usually a page or a block can have 512 bytes or maybe a different number of bytes, depends on your address space. And there is another segment. So actually the memory are segmented. It chopped into block. So each time you load a block into your memory, into your CPU's cache. Okay, cache is a buffer to buffer that. And then for our program, actually, we need to calculate the relative address based on that address. So it will be something like this. There's a, no, this one's MAC address is different. So let me see. Here, let me see. Here's protected base. Let me see. So you have a base address that will be global or local discretion table, and it plus some segment address, and then it will find a real address for a certain instruction. Okay, so that is some calculation scheme you will have. So basically, right here you have a global. This one is better, a better chart. You basically has a 16-bit selector that choose a segmentation table, and then plus your offset. So basically you have main memory, and each one have a block, right? But here are a lot of blocks. So the segmentation descriptor actually pick up not all the segment, maybe this one in there, this one in there, and some of them not in there. Just there is a frequent use address being stored in the memory, and then it will use that as a segmentation address plus your local address that's relative to your local block. And then use that two address sum together. So segment address plus a offset address. Offset means starting from the starting point to a certain point. Now you get a 32-bit linear address. That's the real address you address your memory speed. And for 32-bit means 4 giga. Okay, in the past, 4 giga is a memory space for Unix for quite a while, but now it's actually passing this. The address space is way bigger than this now. Okay, in the past, using the 32-bit 4 gig memory address space. But that actually right now has become not as big, not enough right now. Okay, that part is for assembly part, but here actually let's look at the memory address. A memory divided into one byte pieces individually addressed. Minimum data you can request from memory is 1 byte. So you can address byte by byte, but usually nowadays your system bus say I have a IA64 instruction architecture 64. That is my microprocessor x86 architecture. The newer one is 64-bit. So system bus carries 64-bit. That would be 8 bytes. So 8 bytes being shipped in 2 bus at a time. Even though some 8-bit you can individually get it, but now if your system bus, say we call a computer is 64-bit, that means the system bus is actually 64-bit plus some data bit, some control bit. So there is a control bit, some data bit. Data bit is 64-bit, and then there will be some address bit. 3 kind of data being shipped onto the bus. We call this 3 bus. 3 bus means control plus address plus data. So what control means? Control means like share or load or write to memory or read from memory. Those kind of control signals. So there is a read or write on the bus. So that determines your memory. You have a bus and your memory, whether it's a read, is a write, or is a read. That controlled by the control bits. And then address, which one I should pick. That one is address. And other than that, you still need to have the address. Address, that the data flow into the bus. So you either write into here or read the data from the bus. Okay. So a single character can be addressed by certain address. Every one of it is like that. And for 32-bit processor, the address can be up to 32-bit, and that is actually 4 giga. Address can be up to 40. So to uniquely identify the addressable byte by this, you end up 32-bit address. But now we are using 64-bit address, so it's a 4 gig times 4 gig memory space now. So depending on the compiler system, computer system bus, memory allocation not be byte by byte basis. So right now, usually 64-bit, it will be 64-bit will be read. And if you just want to pick up 8-bit, some of it will be actually just ignored. So it will be just ignored. Okay, now we have these different symbols. So this one, what's this one? What's star? Eric, you still remember?
Pointer.
It's a body, right? And if
yeah, body.
If you declare body, PC's body is integer, then that is a pointer. Okay, so you can actually use that on the left side. When this star used on the left hand side is a body, it's actually a memory location that you can write data to. If it happened on the right-hand side, it actually is a pointer address assigned to other people. Is that okay? How about this S sign?
Address?
It's actually address in C, right? But in C++, it also works as alias, right? How about this one? Dash arrow, dash greater than.
It's like for functions, but it's for.
This one official name is called dereference.
Dereference? Okay.
Yeah, usually you reference something, right?
Yeah.
This one is dereference. So I have a pointer, but actually I dereference it to a certain object, and then there is a data field, like integer x or something. So I can use pointer dereference the x, right? And that actually is the object you pointing to is x ages as data field. Okay, so that one's for that. Plus minus sign is used for what? For pointers, plus or minus sign is actually to advance the pointer or decrease the pointer, right? Pointer is calculable. And what is the size for pointer in C language?
I don't know.
It's an address, right? So it's actually 32-bit. Remember that? It's just 4 bytes, like integer size. 32-bit integer size will be a pointer. So that apparently, like in C language, you are actually following the 4G space, okay? And if you need more than that, you need to learn how to do segmentation management in C language. It's doable, but not easy, okay? But not beyond our scope. Size of will be checking for the size of a pointer or a variable, okay? So if C is a variable, we may use a PC or CP as a variable name for the pointer, okay? So usually I use PTR or P or PP for second level pointer. So this one, it should be read as the body of the pointer or object of the pointer is a integer. So its PC is a pointer to an integer. This one read as the address of C. Okay, so address of C assigned to a pointer as assignment. And then pointer is a variable that holds the address of some other variables. Okay, so it actually is indirect accessing the variable. It holds an address, and that address is the address of the object or variable. Body C means the object of the pointer. It means the variable that the pointer PC pointed to. And then PC is which star is an integer variable. It is usually used on the left-hand side as a variable that you can update. And body of PC is used exactly as C if C's address is stored in PC. Okay, so this chart I can show you the very simple definition, but I think you already know this, but some terminology still need to learn. Address of a variable, each variable that is declared is stored in memory. So memory is indexed. Each variable will have an address. So C allow programmer to access the address, and Java doesn't allow you to access the address. A unary operator assign means address of. Now we know. Since constant expression do not have permanent storage, they don't have address. So constants and expression like a greater than 2 that has no address. It's just a value that will be determined in your CPU. So usually when there is an address or pointer, it means that will access the main memory. That actually is a slow operation. Okay, usually slow operation. Something just by assignment by those constants, those are actually register-based operations. So you have a CPU, you have a main memory. So some computation like A equals 1, it actually can be done purely on your CPU. You don't need to get off to main memory. But if you have that like A equals B, there's a variable you need to fetch, put into CPU. That actually is slower, so that actually need to access memory. Is that okay? Hello, Eric.
Yeah.
Is that okay? So right here, I give you more idea about the computer organization and architecture. So it would be strongly related to the 51 course. Okay. So now this is available. Each variable has a address and a value. This is 3-in-1 combination for available. In C language, you have access to address. Most language, they don't allow you to access address. They only have a variable name and value. Okay, so pointer to a variable. If variables have address, can these be stored in variables and manipulated? Yes, those variables that hold the address of some variable is called pointers. So we declare as data type. Body of the variable is not data type, so the variable itself is a pointer. In this example, one pointer variable had been declared as P, and it can store address of any integer variable. Okay, that's fine. And if I say, is that possible that I do this? Say, let me bring up a new issue. Okay, let me bring up a new issue. So right here, let me new a project. Okay, you probably never see this before, but let me actually show you. There is another type, a new type of the pointer. You may not have learned it before, but it will be very useful. In fact, it actually is very useful. So chapter A, right, let's have this project one. So here, let me call it boy pointer. You probably never use this before, never see this before. But it's possible that you have a void pointer. So here, let me take this out, right? And then I have an integer A, and then void pointer, body of P equals address of A, okay? And then A equals 3, right? And then print F. Yeah. Okay, let me put it pretty simple. Okay, that's wrong. Okay, it's not allowed. I think it's because I need to use the flag. Okay. Okay, still not working. The reason why this doesn't work, it actually is because this one is a void type. But here actually I can do this. I can do this. I'm sorry, it's not like this. It's still with the ages. So here I can actually do this. Convert it to a pointer or convert it to a pointer or of integer. Is that okay? Is that okay for this one? What's the advantage for this one? I have a pointer. Here has an integer A. I may have a double B, right? And then this one, I can assign this to P, right? So now, and A to P, and I can also assign ages of B to P. Let's try this again. Okay, so this one, it is a versatile pointer actually. So after this, I say here, if I have a double B equals 5.0, right? Right here, P equals address of B, okay? And then let me copy these things down over here. Okay, and then here I say double body of that. Oh, okay, long. You see the advantage? What is this actually? You should call it. If I let me you if I let you a name for this pointer, what should you call this P? Void type of P. It actually can point into anything, right? It can actually point into anything. So it's like typeless pointer, right? But typeless pointer actually can load any type of pointer into there. Is that okay? Is that okay?
Yeah.
So here, even this. Will this work? Will this work? So ages itself, you can actually adjust the type. My integer can be assigned, my integer ages can be assigned with the character ages. And the result is A. What does this actually mean? What does this whole thing actually means? I have an A, that is actually an integer. Integer, how many bytes for integer? Integer, how many bytes? How many bit?
4.
4 bytes, so 32 bit, right? So actually 0, 0, 0, and 3 over here, right? Is that okay?
Yeah.
So this one actually, I give the ages of the character to Q. So actually, I'm not giving this ages here. I'm not giving the ages for the integer. I actually only give the ages for this guy to Q. So actually Q now pointing to here. Is that okay? Now Q pointing to here, right? And the value now is actually, so I have to change the ages of A. It's actually integer pointer type, but I convert it to character pointer type, so it actually converted to here. But the value is actually the same. You know, my ages of A actually the same as this. So I actually get that ages value, and then I add 62 as a character in there. So this one actually I add 62, it becomes 65. And 65, I print out the body of this Q. Body of this Q is 65. And as a character, and that one as a character will be A because it's ASCII code A, 65. Is that okay? So
Yeah.
this shows you the superpower of the C language, that you can individually, as it said, individually address each byte. And if you use the bit level operation, shift right, and then and or, you can actually access each individual bit. Okay? And now something you need to learn is the big endian and little endian now. In Intel processor, there's a big endian and little endian. Let's just use Intel. Intel, I remember is using little endian. Okay, here has a big endian and little endian. So actually, Intel processor is using little endian. Okay, what's little endian or what is big endian? So if a value say D7C4, okay, D7 is bigger, right? D7 is bigger. So D7 is bigger, so D7 is put into the higher bit. And the end, the lower part is called little endian. So that's why when we actually write an integer, right, it has 4 bytes. In fact, it stores 3 at the front, 0 at the end. And then this one is the last 0. So this one 0, and then this one 0, and then this one 0, and then 3. The real integer you read out is something like this. Higher H is more significant. Higher H is more important. So smaller one put in front, that's called little endian. So that's why when I have an H's of A, I actually access the first byte, byte 0, byte 1, byte 2, byte 3. Byte 0 is the lowest, this is significant byte. So when I read that out, the H of this converted to character pointer, it actually gives you 3, and then I update it with 62. You end up 65, and that's hexadecimal, 41. That's ASCII code A. Okay, because I try to get the first byte. Get the first byte. That's little endian. When you have a big number as an integer, larger number, more significant bit put to the larger address. This significant bit put at the lower address. That is called little endian. Is that okay?
Yeah.
So the value is 0.00001C2. So C2 put on the lowest address. So say if I have an address here is like address like A0, it would be this. A1 address would be this. A2 byte would be this. Is that okay? And then this one would be A3. Okay, so you need to know about this one. And who is using big endian? Intel is using little endian. So Intel, the lower byte is byte 0. Okay, who is using the big endian? Motorola is using that. Motorola is the PowerPC and then Macintosh computer for a while. Okay, so at that time, the Intel processor and Motorola processor were not compatible, and you need to take care of it. But now for Intel, you just think about little endian. So that's what you need to learn for your 51 course. So here you have 32-bit integer, right? So address 0, A is address 0. You get this. You get this. A1 will be C. So least significant data on 0. So let's do this. Okay, let's do this. Oh, we have the 0A, 0B, 0C, 0D, right? Let's do this. Let's do this. The integer, let's do here. Let's say A equals 0x, 0A, 0B, 0C, 0D. Right? So D is actually least significant bit. Right? So what I will get would be 0D, right? 0D, 10, 12, 11, 12, 13, right? So what I should do is right now I get the ages, and instead of adding it to 62, and here I actually print out in hexadecimal format, right? So what data will I get right now? 10 here actually is like 10, 11, 12, and 13 for 0A, 0B, 0C, 0D, right? Which one? 10, 11, 12, 13. Which one I will get for this Q now? You will get a least significant one, right? Which one is least significant here? The D will be, right? That's right. That's right, whether it's D or not. That's right, whether it's D or not. Okay, you got D, right? You see it's got D, right? So now if I do this, if I do like, let me do this Q increase, what will I get?
E?
You get C, there's no E.
C, and then B, and then A, and then X.
Yeah, you actually advance the edges, not advancing the. So let me actually continue to do this. Okay, I keep doing Q plus plus. Okay. Q plus plus. So this is Little Indian, okay? Remember this guy is called Little Indian. What it is like, when my computer store my data in Intel, it actually has, it is not really stored. So here, if the address here is A, right? So A's address I store 0D, A plus 1 I store 0C, A plus 2 I store 0B, A plus 3 I store 0A. Is that okay?
Mm-hmm.
And then here, after I store the address to Q, I address individual character, that would be this one, right? And if I have a Q here, right? Q increase, I move the Q to here. So get C, get B, and then get A. Keep increasing the pointer. So increasing the pointer here, actually increasing by a character. Increasing by a character. Is that okay?
Mm-hmm.
That one increasing by a character. Let me clear this. And then that's increasing by a character. And run. So you have a D, C, B, A, right? Now let me do another thing, different things. Here I have integer, and then here I have like a C array of 4, right? And that guy has the data 10, 20, 30, and 40, okay? I have an array that has the data 10, 20, 30, 40, right? Now, here I have the integer pointer PTR. It get the address of C, right? C array, and C is actually an address already. I don't need to put an address sign over there. If I want to put an address sign, it should be address of 0, right? Remember that?
Mm-hmm.
And actually C has exactly the same as the address of 0, right?
Mm-hmm.
And here I actually need to put a star for pointer, right? Now let me actually copy the whole thing down, okay? Copy the whole thing down. Copy the whole thing down over here. Okay, now I need to replace my Q with PTR, right? Now I need to replace my Q with that one. So actually let me replace. So top part would be Q. Lower part, the thing I want to replace with PTR. Okay, and then forward replace. Oh no, this one no, this one actually. This one actually should be. Let me see. Actually, is like this one final. Next. Okay. Wait, there is no next function over here. Let me see. Is there any next? This one really not really user friendly. Let me just type. Okay. Let me just type. It's not really useful. Okay. So each time I increase my pointer, right? So what is the first number I print now in PTR? The body of PTR, what's the first number I print now? I have an array of 10, 20, 30, 40. Which one I print now first?
10. See.
What's wrong? Wait. Here, what's that?
Do you not assign the right?
What?
Let me see.
Let me see. Conflict type with PTR. Oh, body of the two. Here, let me put a number. Okay.
Should be 10, 20, 30, 40, right?
Yeah, let me put this. Okay. We will differentiate. Wait, I have a definition for PTR already. Where is the PTR? Let me see. Oh, okay, this one I actually modified it without knowing that. Okay, the refresh function refresh for me. So that means wrong is actually 10, 20, 30, 40, right? Oh, why am I giving you this example? What's the trick? What's the trick? How come this still be important? What's the trick right here?
I don't know.
This one is a character type, right?
Yes.
And then so what is the size of a character? 1 byte. 1 byte, right? How is the size of the integer?
4 byte. 4 bit.
What is the character in Java?
I don't remember.
2 byte. Okay, you have to remember all of these. Okay. But in C, character is only 1 byte. Okay, you always need to remember these numbers. Okay. Anyway, right here when I do Q++, okay, each address is actually 1 byte, right, for character. But here the actually Q is increased by 1. And how about this? How about this PTR increase?
By 4?
By 4, yes. So it's by size of what? The date pointer type. By size of the pointer type. Is that okay?
Yeah.
Pointer actually, like if you are pointer or character, it increase by, when you do plus, it increase by 1. If you are a pointer for integer, it actually increase by 4. Is that okay? That's something you need to remember, okay? When we talk about the calculation for ages, that this one is increased by 4. Is that okay? That's really, really important, okay? If you have some tests, it's easy to test something like this. It's very easy that you would test something like this. That's why we touch spaces on some pointer before, and right here I'm still teaching you these different pointers. Okay, so here it has the pointer to variable. Remember that a pointer to variable, this one is called dereference. Okay, dereference is to get the body or get the object. Okay, and then address of something is a floor type data. Okay, so actually this one is a pointer. So the body plus something that's operation on the body, the variable. And then if you have the operation on the pointer, it actually is advancing the pointer. So you can assign a address to a pointer, but remember what you need to take care of. Remember that these two need to be on the same type. If not, you have to convert it to character star or integer star. Okay, so initially you can actually declare a void type, right? And later you can assign it with any different type of pointer or address. Okay, you can assign with any type of the pointer. And then if you do increase, that's based on the pointer type. Okay? If you increase based on the pointer type, it's not really +1 +1 +1. So let's go back to our program. Okay, let's go back to our program. So right here, let me print, instead of printing now, this one, let's print now. I directly print out Q. Okay, I directly print out I print out the data, and here I also print out its related ages. And you will know, because it's actually an integer type data, so you will know what's going on there. Okay, what's the change of the pointer. So here, let me do this one as PTR. Okay, so I told you that this C plus has a lot of detailed things. So the way teacher teach, like in 1 quarter, trying to finish C plus up to the object level, it actually too much, too fast. Okay. So here actually, oh, I'm sorry, I forget to put the backslash n there. Okay. So I need to put backslash n. And it's a lot of work actually. Okay, it actually is a lot of work. You can finish the C plus basic course in 1 quarter. So something that told in the end that's actually is slower, that's actually good, but it's somewhat not difficult enough. But slower actually is good. You know, I don't actually suggest to rush it. But now, let's see. Okay, so as you can see, the pointer for Q actually advanced by 1, and then integer advanced by 4. Is that okay? Apparently, if you actually print out the data, it actually advanced by that. Okay, so that actually tells you that the size of the different data type do matter if you try to advance the pointers. Okay, so that one is this. And then let's go to the next one. That one is assignment of the data. And then the value of a pointer is the address of an integer variable, and it's actually is take the modular 4. Each time it advanced by 4. Okay, so your body can be assigned with some number. Your pointer can, you actually can assign a specific address for you, but actually it depends on whether you know that address that well or not. If not, try not to do that. It's actually dangerous. Pointer to a variable, the dereferencing. This is dereferencing of this. So if you dereference a variable, is actually star p. If you do dereferencing for data field, it will be p arrow with x. Okay, both of them we call it dereference. Okay, to find the body is actually called dereference. Either you find a body for a certain variable, or you find a body in a structure or a class. Okay, that's called dereference. Is that okay? So the legally to start use this on the left-hand side is okay. You can assign value to that variable. And then address is, this is address of a photo type data. It is not compatible with integer pointers, so we convert it to this. This type of pointer is called generic pointer type. It's compatible with any other type. So it's actually quite useful. So here we have this one, that's F, where is F? Right here. Is a pointer to address to pointer. But here I have another one, P, right? I have another one, P, and that P is actually what? It's a pointer to integer type. So you can convert it to a void type. So void type actually, if like there's an A type to B type, I can convert it to void type pointer, and then that will be compatible with B type. Or you can assign a address to a void type P, and then void type can convert to certain type you like. Is that okay? So if you put a percentage P, means that it's actually a pointer type. It will print out a address. So here, this one pointer B is percentage D. that would be print out the value of it. So you need to put a body or a pointer, then you print out pointer address. So this one is a type data type for P. This one is a pointer type, so you print out some address value like this. Okay, that's a pointer to a variable. So right here, I have a more complicated example. This one, let me try to get it. The example is called pointer to the C. Let's look at it. Okay, it's a little more complicated, but you will learn something from there. Okay, you will actually learn something from there. Okay, so let's bring up the pointer to the C. Let me save. Let me open the pointer to C. So it's in my demo program, chapter A, and then pointer 2. It may be in pointers. No, this one is pointer 2D. Wait, what is the course I'm looking at? See, chapter 2, and then let me look at ages. No, this is not ages. Pointer, okay, there's a pointer 2 right here. Okay, pointer 2, I have A and pointer to A and pointer to pointer to A. These three examples actually will be I have a variable, I have a simple variable A, and then I have a pointer to A, let's call PA. I have a pointer to pointer of A to PA, okay? Then I have another one, I have a B value, and then I have a pointer to B value, copy B is like this. B assigned with 10, right? So I hook up A and the pointer of A, and the pointer of A. A assigned with 3, so here we have a 3. If body of PA is 3, we print out this. So actually the first one is body of A is 3, yes, so this one will be checked. Okay, and then if body of PPA is 3, so it's body of A, 2 label body, 2 indirect edges, and so this one is checked. So these two should be checked. And then PPA get edges of B, so edges of B is actually the value of the value of this put into PPA. So actually PPA now pointing to this one, the B. Okay. And then see how it updated. And then body of A increased to 6. And then edges of A assigned to PPA now. PPA now actually assigned to here. Okay, so it's already become complicated. That's wrong, and then see how it works. Okay, the two
You have 1 star?
Yeah, you have 1 star, 2 star. That's just
Yeah,
wrong.
can you have 3 star, 4 star, 5 star?
Yeah, it's possible. If you so the first two are checked, right? So now the next thing is like let me see. When PPA updated, see how PA got updated. Okay, so now we have, let's draw them again. I have a that's put a 3 in there. I have a B that's 10 in there, right? And then I have like PA pointing to here. I have PPA pointing to here. So pointing to there means that you assign the edges of PA to this. Okay, and I have PB not accepting the edges of these. Okay, now the PB got the edges of B. That's correct. Okay, and then the next one is if I have my PPA's body. PPA's body means what? My PPA's body got a B's edges. PPA's body. PPA is right here. PPA's body actually is PPA is here. PPA's body is here. It got a value of HSB. So this one pointing to here. Is that okay? So like this one, actually, if you print out body of B, PA and B, it actually is 10, 10, okay? The 10, 10 right over there. The next one, PA's body assigned with 6. So because PA pointing to here, so this one becomes 6. This one already dropped, okay? And then PPA's body update by 7. PPA still linked with that, so PPA's body update with 7. So here is 7. So after this, I print out PPA, P star A and A. A still will, A actually will be, let me see. Wait. How comes A got affected? Oh, this one address of A. Oh, okay, I'm sorry. Here has the address of A assigned to PPA. So I'm sorry. Here I need to update. Okay, I need to update a little bit. So that's actually for 7. I haven't assigned this. For the red one, we finish up to assignment 6 to V and PA. Okay, so up to here. When you run down to here, it actually up to here. It actually up to here, and then I'm sorry, yeah, up to here. So actually the PA's body actually is 6. Okay, and then B's value is also 6. So that two actually that's 6, 6. Okay, and after that, PPA's body, PPA's body actually is PPA's body actually is PA update back to A, back to A, back to A here. So you convert it to here, you drop again. So here now you assign 7 was here, and then this 3 actually has the same value. So all 7s over there. It's all 7s over there. Okay, it's all 7s over there. Is that okay? So you can a second level pointer, third level pointer, fourth level pointer, but second level pointer is used to update the first order pointer's value. Third order pointer used to update the second order pointer's value. Is that okay? You use the body of it to update it, especially when you call into a function. Okay. Next one, pointer and function argument, functional argument. So here I go into a lot of detail because I'm afraid that the sentence data, the coursework, it will not be easy. Okay. So here, pointer and function argument, you have swap. Okay. So right here we have two, swap 1 and swap 2. Which one will work?
Swap 2.
Swap 2 will work. This one actually.
Swap 1 doesn't do anything.
Doesn't do anything. Yeah, it actually is like swap this local A and B. Okay, because of pass of by value. So here actually A and B cannot.
But if you put the print inside swap 1, would it work?
Put the print inside the plot 1 will work, but the outside A and B will not be changed.
Okay.
It doesn't help. Okay, so pass by reference in C, actually you have no reference available. You can only use pointer as a reference. In C++, you have the alias that work as a pointer. And pointer actually, I'm sorry, reference. And reference is actually what? I usually use the name left-hand side. You can accept change, okay? Reference is actually the left-hand side. And pointer is indirect addressing, okay? So remember that. And here we have double this, and then function of putting the address of this. So the function actually accept the pointer. So actually you have the address of this. So P actually pointing to X1, okay, X1's location. So you print out P itself is the address. So you print out 5445004. And you print out body of P will be this one long for double type. It actually will be what's that? Actually, so it will be 4. Okay, it will be 4. Is that okay? And now the next one is the array and the pointer. Array and pointer, actually, I show you already. Actually, you can start with a integer. If you declare an array, it's simple like this one, right? And you put 1, 2, 3, 4 array, right? And you can also do unknown size, okay? That's also fine. And then you have the pointer integer p. Integer p you can assign with a. Then p can also become a pointer array, so that p you can also do the same thing. Is that okay? And then if you do p plus plus, you actually will update the pointer. Okay, and then if you do body, you can still access some array element, or you can do p plus 1, not updating p, but actually you can use that. This one is the same with this one. When you have p of 1, it's actually the same as p plus 1's body. So p of 0 actually the same as the body of p. Is that okay? Same thing. Right hand side, left hand side, talking about the same thing. So a character pointer point to a single byte, an integer pointer point to the first byte, and it will be lower edges by 1. And it's lower, it is the little endian, so it's the least significant and lower edges 1. A pointer itself has edges where it is stored in the memory. Pointers are usually 4 bytes. Okay, pointer of different type, they are all 4 bytes. And then to get the body or object of, we call it dereference. Okay, so we know this already.
But I thought the arrow thing was dereference.
Both. Arrow thing is dereference to a data field in the structure.
Okay.
And then this one is only an integer, so you still use the body to do dereference. Is that okay? So right here, I have a pointer to integer. And then I assign the edges of x to it. So the body now is 1. And then I can actually assign the body of IP that will be 1 to y become 1. And then I can actually assign the value to body of IP that will be x become 0. And then I can get the edges of 0 location of z to IP. It's the same as the assigning z to IP, since z is also a pointer. Okay. For any type t, you may form a pointer type to t. Pointer may reference a function or object. So it's also okay that you reference to a function. When you reference to a function, you do this. So you do read to the right is a function. What type of function? Is a pointer to a function. Okay, something like integer, this one, a, this, right? You took read to the right, what it is a array. Array of what? Array of pointer to integer. Okay, so this one you read to the right is a function. What kind of function? It's a pointer. It's a pointer to a function. Is that okay? That's how you read to the right and then explain it to the left. Okay, that's how you do C++ language reading for this complicated pointer dereferencing referencing. So read to the right is an integer. Read to the right is an integer. What's that? It's a pointer. The body of J is an integer. Okay, something like that. So here is a function. So I have a function prototype right here, right? And then I assign this one. Actually, my function assigned to a pointer, and this pointer is a function. Is a pointer of function to point. Is a pointer to a function of integer. And the value of my function assigned to the function pointer. And then I can actually run fptr of 4. I actually will run this my function with argument 4. Is that okay? So this one right here, when you read it, it's a function of integer. What type of function? It's a pointer to a function of integer with the integer parameter. Okay.
Uh-huh.
So pointer issue to generic pointer. Other pointer can be casted to, into, or from. So traditional C use the character star, standard C use void star. So the old type of the generic pointer used to accept everybody's pointer is using character star. Now we update to a void star. Okay. And this cannot be dereferenced because there's no body. So you have to cast it to different data types. So if you have a void type pointer P, you cannot actually print it as you cannot actually print it as something. You have to cast it back to character type pointer V P. Okay, then you can actually print it. Or actually, you need to convert the integer type of P. So to convert it so that you can actually be able to use it. Okay, so sometimes really this that can give you the right way. And the null will be 0. Null is be 0, okay? In C, then 0 always reserved for special purpose. So array is a declaration of such a form. And in order array, it's not allowed to assign the value on the right. But nowadays, okay. So here is a fixed size array. Okay, so fixed size array, you actually array and structure, there's a major difference, right? Last time we talked about it. Array is always reference, and then it's always an address, right? But the structure actually is a physical structure, right? Remember that? So array cannot be don't have the aggregation operation. You don't actually have the copy constructor. So if you assign an array pointer array names a value to another one, that's a pointer to pointer assignment. It's not actually copy the whole structure over, okay? But structure assignment is an operation that you will copy the whole structure to it. So design issue in arrays, you have array data type, array pointer, array address calculation, array memory allocation, and array initialization. 5 different topics to talk about. The first one is a pointer to an array. So as I said, the starting address, you can use the address of A0 to a pointer, but effectively it's the same is with that P equals A, okay? And then after that, you have on the top, you have star P would be a body of pointer, and the A of 0, these two are the same. And body plus 1 by character size, something like that. You will have all of these are of the same value. Is that okay? And then array accessing an element. So you can actually have A of 0, A starting address like this, right? A of 1 is actually, so it's actually like, the address calculation is like, my A has an address, right? So I have this A of 1, it actually, A of X, I say, it actually is the A's address plus size of int times I, right? That will be my new address for a certain A of I and use that to access to the memory. Is that okay? And then 2D array actually is what? A of ij will be what? A plus A's address plus what? Size of integer times j, right? Times size of integer times size of number of column times I, right? Are you okay with this?
Yeah.
Okay, that's how you calculate the real address for it. If it's 2D addressing. That's a little bit more complicated, okay? So to real data, you do this right like this. Array is a collection of variables of the same type. Okay, we know. Declaration is like that. So you can declare like this. Reinitialization. Okay, you have static initialization, and you can have the for loop dynamic allocation initialization. Two work similarly. And then polynomial.c, you read a coefficient of a polynomial and put in the table of value for all of these. Okay, this one is actually the same with what I want you to do in Python, the homework, okay? Remember that this morning I sent out a homework? So this one is actually a polynomial problem. So the polynomial problem is like, I want you to do if, let me see, coefficient of the 0. So actually coefficient of 0 would be C0 plus C1 times X plus C2 times S squared plus Cn minus 1 times Xn minus 1. Is that okay? That's the polynomial you have.
Mm-hmm.
And then put every X in there with that coefficient, you should actually get the result for, so you should get result for each value. So this one is to evaluate, f of x. For example, like x squared plus 2x plus 1, okay? Then you need to do it in the coefficient. Let's do that, okay? Let's do that, okay? So now, it actually asks you for the order, so let's do that. So I have that polynomial, let's see. I open, and then there's a polynomial, let's see, right here. So it actually enter the order and then enter the how many coefficient, and then evaluate the polynomial function. So let's get started. The order that we do this second order, right? A0 is 1, A2, A1 is 2, A2 is 1, okay? So like this one is actually, this function is actually 1. It's actually x squared plus 2x plus 1 equals f of x. It's actually x plus 1 squared. So you would have the line of symmetry at here, minus 1. It's actually something like this, okay? Something like that. So starting from 0 to 1, right? Putting out the data. So starting from 0, you will get 1. So 0, you will get 1. And then, let me see. 0, let me see. 1, 2, 3. So, and then the last one actually is equals 1. 1, you should get 4, something like that, okay? And this window is not wide enough. Let me actually for it to be wider. It doesn't include the last one. Let me see. This equation is that correct or not? Coefficient times power x to the power something. So starting from 1, I times the x to the power or something plus coefficient I. That's correct. Plus to the value. Okay. And then for all the points from 0 to 1. For all the points from 0 to 1, my equation is x squared plus 2x plus 1. So if I have a 0, that would be 1. Okay, something probably tricky over here. Something is tricky over here. Okay, anyway, but this is the way to evaluate the polynomial, okay? And I'll check the function, okay? The next one, HS calculation. Okay, HS calculation. It's a calculation for pointer and that. Okay, you can assign the starting edges for an array. This one and this one is actually the same for array to a pointer to our array, right? And then you can use that this and these two are equivalent, right? However, since a is a constant pointer, the following is invalid. So you cannot assign PA to A is what? A is a constant or something.
Mm-hmm.
So actually, or if it the array name is a constant pointer, so what's that? Not because you cannot assign to it, but array's value. So if you have an integer A array, something like that, you cannot do like my PA assigned to A. No. Why? Because it's a constant pointer, no change. Right? So when you declare this, A is no change. But when you declare this PA, that yes, okay to change. Is that okay?
Mm-hmm.
Actually, okay to change. So a single A probably only assert the first time assignment. So array and the pointers, a variable declared as an array represent a contiguous region of memory in which the array element is like this. Okay, that's fine. Array to start with index of 0, like we know. Okay, this should be easy. Okay, so pointer in C, we have this, and put into the memory that I think it's fine, right? And C level process, that's next one. Pointer continues. These are the same. I talked about it already, so let's go. Pointer for this. You can actually provide a certain single character address and then convert to integer pointer type. So these are just basic some calculation of the variable of different type. Okay, so it's fine. Pointer arithmetic to help you to do plus minus 1. I think this is one is fine. I will avoid it. Okay, I'll omit it. Okay, pointer arithmetic. So you can do plus minus, but be careful. If it is out of your array range, then sometimes it will not work. Okay, that's
Okay.
the arithmetic. A 32-bit system has 32-bit address space. To store any address, 32 bits are required. Pointer arithmetic plus 1 give you the next memory location of your type. Okay, not next byte. Okay, pointer arithmetic very operation. You can do this, and you can do this. Okay, you can do this. That's it. So you can actually calculate different things and then access different number of different size, and then try to print out that. And here, because it's a percentage of P, you will only print out the pointer. You will not print out the body. Okay. Let me check. Okay. So right here we are page 39 and we up to 102. So we finished the array part with pointer.
Okay.
Right? So next time we'll go back to pointer to string because of character type. Is that okay?
Okay.
Okay. So that's it for today.
Okay.